So we're going to talk about science and our connections and how those work together, and in particular about what we do at the museum and the programs that we do. Just a little bit about our pedagogy. Anyone know Fred Rogers, what he said to parents when asked, how do I prepare my child for kindergarten? Anyone know? Well, that's my Fred Rogers rule, and this is the most important rule I think that we have is, from our pedagogical perspective at the museum, is to give them imagination. And really, that is what kids need to be able to start thinking in a way and being creative and go all these different places, and really creativity, and you can see it in our mission statement, inspiring curiosity through exploration. It's really important at the museum. We want people to mess around. We want them to try things. And we want them to be scientists. We want them to be scientists and take on those qualities of a scientist. Curiosity, you know, that quest to figure things out. I wonder why. We encourage kids all the time. We want them to say, I wonder why. Take risks. And I can tell you, as soon as I walk into a class, I know what I'm going to expect. We got little elementary school kids. They're willing to try any answer. And you raise your hand all the time. You start getting into middle school, they might not want to do it that much. We have a tendency not to want to take risks. We don't want to fail. But that's what science is all about. It's trying things, messing around, failing, trying things again. So we want them to take risks. We want them to, you know, be willing to try and figure things out. And it's okay if it doesn't work the first time. And there's that humility involved. So we're looking at it from the perspective, there's so much out there that we need to, that we can possibly know it all. And we can look to nature for a lot of those answers and things, and looking at nature's design, which we're going to do today with all the cool stuff on the table. Looking at nature's design to figure out how we can figure things out and try things and develop and design things that will work. Because nature has all those many hundreds and millions of years of R&D that we can tap into. So when you look at those things and you look at that imagination, you can see right away there's great connections between science and art. We want them to ask questions, certainly you hear about inquiry and things, but we want to also make sure that they're asking open-ended questions, questions that they can figure out for themselves. So instead of, you know, what's the fastest land mammal? Anyone know? Yes? Cheetah, exactly. Cheetah is the fastest land mammal. You know, and those are the type of questions. I started my career at the museum 17 years ago doing outreach in schools, and I would get that all the time. And it's like, you know, those questions you can just go to on the internet right now and figure out. But a better question is, why is a cheetah the fastest land mammal? And that's the type of thing they can start looking at, and they can maybe look and make they can look at their own cats and to figure out that a cat, and especially if they have a cat and dog, but most kids have seen cats, they can look at a cat and then they can understand that a cat is a really skinny body because their hips are positioned different than ours, certainly, and dogs. They basically extend the length of that leg. And if they look at an anatomy of a skeleton of a cheetah, they can also see that the spine is really flexible. And all those adaptations that it has is what makes it a fastest land mammal. So instead of just saying, you know, what is it, and all those facts, it's really looking at it and trying to figure out why. And I love to do it in a way that they can take something that they already know, that constructivism, and then figure it out and apply it to something else. So you want them to be able to see connections between different areas. So we like to throw away the boxes, and we like to think from a whole systems perspective. We don't want to just talk about science. We don't want to just talk about economics. And really, that's the way science is going. You've got social economics. You've got biogeography. You've got all these different connections. So science is going in that direction. You've got designers working with scientists to create new things, and biomimicry and a wonderful thing. So you've got those biologists at the design table. So there's always, in trying to get kids to think broadly, even from a science perspective. You know, we still teach biology, earth science, chemistry, physics, but looking at it and understanding those connections, looking at a tree from a biological perspective, but looking at it Well, it's one of the most efficient pumps in the world, as it uses capillary action to get that water up through the xylem. And we're going to talk about capillary action in a little bit, so show cool ideas. But really, we really want them to think broadly and to think out of the box. We don't teach at the museum, we facilitate learning. We really is about our audiences taking ownership of their learning. We want to guide them in that way. We want to teach them how to ask good questions. We want them to, we model that ourselves. And that's why I always ask, I wonder why? I wonder why that? I wonder if you try this, what would happen? So you're getting to the point where you want them to do that on their own. So really, the goal, I think, is to create lifelong learners and to see those connections and have fun in learning. And we certainly want to personalize it. We want to have authentic learning experiences, things that they can relate. We want the museum to be relevant to them. We want them to realize and say, oh yeah, you know, when I learned that at the museum, and you can apply it to other things. So that is really important, in making sure that science is part of our everyday lives. So we want to make sure that they're connecting to that. So when we first, and I mentioned about giving an imagination and things like that in science, one of the very first skills that you need is to look at things, to observe, to really see things. Because it's really not knowing names as much as seeing it that really helps you to understand it, because a name is just a label. And I came across these phases of observation, and believe it or not, they're not from a scientist. Guess where they're from?
Artists.
They are. They are. It's Thomas Wolfe. He was using his phases of observation when he was critiquing and looking at landscape paintings. And he used it, and the first one is the naked eye. So why don't you grab something on your table, something that speaks to you, and we're going to look at it from this naked eye. So basically what that means is just what is it that you're seeing? How would you describe it? What color is it? So what would you say the color is yours?
Not quite a lime green, but it's sort of a lime avocado light green.
Okay, so great. And she's taking something she knows. Now if she says, oh, I just picked up the flowers of the lime green, can you all relate to it? Do you have a sense of the color that she's seeing? You can relate to it. She knows that. So she's taking and she's comparing it to something she already knows. So looking at it and describing it in a way that helps you to see it. And a lot of times, when I say, what's the color of a Coke can? You'll probably tell me, red. Sure, that's what you'd say. But what color red? Is it blood red? Is it fire engine red? Is it a shiny red? I love to tell kids, and I challenge them to go, and I'm going to challenge you, to go this week as you're going to work, look at the sky, and just say what color the sky is every day. We always say the sky is blue. I'll tell you that I live in the Boston Hills, and all I know is that I couldn't even see the sky this week. We've got 2 feet of snow, guys, so don't you complain about snow over here, because literally it's been crazy out there. But look at the color of the sky, and look at it for a week and see how it changes. So really, that's the naked eye. And that's how Thomas Wolfe looked at that landscape. And he pretty much said what he was actually seeing. Then you're looking at through the seeing eye. And this is relationships over time and space. Now, if you're a flower, where would you have to go to understand the relationship of this over time or space? What did it look like maybe?
In the field where it's viewing.
Exactly. What did it look like, a week ago? What did it look like a month ago? Was it even here a month ago? What grew around it? And the best place to do that, in looking at relationships really, is outdoors. And that's really where everything is in context. So it's great to be able to take your kids outside, let them collect something, and be able to see things in that relationship over time or space. Looking at over time. Anyone know what that plant is that I have up there? Not that you need to know names.
Thistle, or also called
It's not thistle, but it's softer than that. It's teasel, but I know you guys see it all over the place. Go on your way home, see if you can see teasel in the woods, or on the side of the road. You don't have to go to the woods to see this. But it's over time. So to the left, it's before his flower. And then if you notice, it's flowering, and it first starts with a band in the middle. And then those flowers die out, and you've got flowers going above it and below it. And then to the point where the flowers are gone and it's gone to seed, and that's what you see now. If you're on your ride home, you might see that teasel in that state. So you probably wouldn't know that unless you watched it and observed it over time, that the way those flowers, Joe, they don't flower all at once. And why would you think that is? What does a flower do for a plant?
Reproduction. Reproduction.
Reproduction, that's right. And so it needs to be pollinated, and so if it spreads its flowers out over a longer period of time, it has a better chance of being pollinated and reproduce and produce seeds, and that's really the name of the game. For plants, it's survival, it's reproducing. Animals, it's finding food and not being food. So it's really cool. And when I share this with kids, I really would love to get them to tag a flower and see, or a plant, and watch the plant over a course of time, because you can see that, when you go by and you think, oh, it's still flowering, but one of those flowers probably died, and it's another one that is opened up on your Queen Anne's lace or whatever. But when I was talking to a girl, like kids, this plant to me will forever be now the purple bikini plant. Love it, love it. Isn't it a great word for it, name for it? So watching and observing it and getting to the point where people really see it, it's not the name, but when they really see it, and that's when they get to know things, and they understand how that plant is reproducing and how those cool adaptations are. The next one's the inward eye. And really, what can you learn from this object? What can I take away from it? So, looking at your flower, what can I learn from it? You can see that you've got a lot of different little flowers that are going to pop open. So, so you can appreciate just the beauty of it, and how the little ones look like the big one, minis of the big one. There's a cool pattern in there. So there's always something to learn from everything. Then the next one is that reflective eye. That's kind of the so what. Why should I care this thing even exists in the world? Why should I care about those mosquitoes that annoy me? But you know what? Mosquitoes are one of the best pollinators around. So we should care about them. What's that role in the universe, and why should I really care? Sometimes you talk about, what if I gave a eulogy for this thing? What would I say about it? And why should we care? And I really challenge people to look at things from those different eyes. And that's really what Thomas Wolfe did when he was looking at those landscape paintings. So I have taken that, and I use it all the time with kids, because there is that connection. And they do speak to us. And I think there is an emotional connection to science and looking at nature, as well as art. So when you look at science and art, it really is about making observations. It's making investigations. It's testing ideas. It's about theories, technique. You hear about technique a lot in art, technology, same base. And so when they come together, that mind and hand come together, you have where the scientist works in the laboratory. You have the artist that works in the studio. Well, at the museum, we have new spaces, and we call them science studios. And we very specifically took that term because we wanted it to be a place where scientists do their craft, just like an artist does their craft, where they mess around, where they use their creativity and they figure things out, where they try things that maybe no one has tried before. And that's really what it's about. It's asking a question that no one has ever asked before, and then trying to figure it out. It's trying something that no one else tried before. So we have developed these spaces. We actually have 2 online right now. One's our Marvelous Earth that talks about Earth systems. The other is Explore You, about our body, our masterpiece. And we have developed programming that shows the art and science connection very specifically, and we really highlight that. But we try to make those connections all the time, and we really try to have a takeaway that the kids can see that connection. And our third one is coming online in June, is In Motion, which is going to be not only physical motion and Newton's laws, but it's also going to be organic movement. So we have a cheetah in there, and we're going to talk about those movements, and we're going to be able to see those things. And we actually have a project that we're going to talk about today that is going to highlight movement to some degree. So we'll highlight that as well. The next one after that is going to be insects, well, invertebrates. We're going to go broader. But and I don't know if we have any musicians in here. We want to make sure we hit that too. And so we're going to talk about insect sounds in relationship to musical instruments. So we want to bring that music in as well. So we're trying to combine those arts and science as well. And of course in nature, there's just beautiful art. I mean, you look at these things and they're absolutely beautiful. And now with different technologies and microscopes that are able to look at things such as, I believe the one on the red with the spiral is a cancer cell that's growing. And the one in the middle is, I forgot what it is, DNA or something from something. So you can see, and when you look at a lot of these, they have one of those patterns in nature. And really pattern is what combines, again, science and art in an eloquent way. Looking for patterns. And that is that if you go to nature and you look at things, you'll see those patterns. And many of these have what type of pattern? Spiral. That's spiral. And it goes back to Fibonacci, who actually was able to figure out a pattern in nature. And he looked at the Fibonacci number. He actually was he figured this out when he was trying to figure out how rabbits reproduce. And he came across this sequence. And if you look at that sequence, what do you notice about that pattern? Yeah, you add the numbers, and then you get the next number. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and that is that Fibonacci number. You get the golden spiral. And if you look at the golden rectangle, I looked at that, and that's really a lot of artwork. If you buy canvases, they're pretty much in those same type of proportion. It's pleasing to our eye. And why wouldn't it be pleasing to our eye? Because then we see it so much in nature. We see that. So I'd like you to take a look at the stuff on the tables, what the first group didn't go crazy with, and see if you see spirals anywhere. If you have a spiral, grab it. Pick it up.
Got a spiral here.
Do you see a spiral in your pine cone there? Yeah, actually in pine cones, I'll let you keep yours over at this one. If you look at the pine cone, there's actually a couple different spirals. You'll see the spiral going this way, but you'll also see a spiral this one's harder to see. You'll probably see it going around this way. So there's a couple spirals in a pine cone. Yes. Anybody else have something they found spirals? Okay?
Peacock feather has it.
The spiraling in the peacock feather?
Yeah.
Do you see it in the artichoke? Great spiraling in the artichoke. Pineapples have a variety of different spirals. I like using pineapples because I get to eat them afterwards. But they're nice and big and very similar to your pine cone. Do you see the spiraling in here? This way. Also going around this way. And also in the leaves as well. They spiral too. Any other spirals? If you want, you can either cut open, if you don't have one to cut, the Brussels sprouts, or if you want to peel it open. Someone from last group peeled it open, but you can see this lovely spiraling in it. And when you do that, I'm probably driving you crazy. I'm just walking all over the place. Oh, well. It looks like a flower. So it's that spiraling, just like if you look at your flowers that you have, you'll see a spiraling pattern in the flowers. Usually in the middle of the flower you see it, and also in the petals you'll see the spiraling. Why do you think we see so much spiraling in nature? And of course, the one that's the most beautiful and eloquent spiral is a Nautilus shell. How does this spiraling, how does this design help this Nautilus? Does anyone know? That's what it looks like.
It adds resistance to pressure, strengthens.
Exactly, exactly. And this is where we're looking at minimal materials, but amazing strength. They're using this type of thing to make bionic cars now. Looking at the shape of a boxfish. You don't think of a boxfish as being so aerodynamic, but it really isn't. It uses less materials. They're making buildings that way, using less materials, spiraling buildings sometimes. And also, the different chambers helps it as far as going, and you probably could talk more about this. Going up and down in water and things. But it's a great example of Fibonacci's ratio and proportion in the spiral. So what about plants? Why do you see spiraling so much in plants? In this pine cone. What does this pine cone do? What does this pine cone produce?
It must be a growth pattern.
Absolutely. There's a growth pattern about it. What's inside this pine cone?
Is it a passageway for water?
Seeds. So this is going to allow the seeds to disperse and to have as compacted, because if you put this in water, it'll close really tight, and it gives you the most seeds per pine cone too. So there's that packing around. It helps in that. It gives a great distribution of things. But also, when you're looking at trees and stuff, and if you look at trees, you'll see the way the branches are, or in Fibonacci's number, the way you can watch and see them spiral up. Those all are ways to get, well, and the leaves are the same way on stems and stuff, but what do leaves do for trees?
Well, they maximize bringing in oxygen and sunlight and
Yeah,
water and
yeah, to
so they
produce,
spread out.
Chlorophyll.
yeah, to produce chlorophyll food. And you're right, to spread out. They want maximum sunlight on every single leaf. So it's that pattern that enables it to get that maximum sunlight on their leaves and enables them to do that most effectively. So, scientists, have been thinking about this a lot, and sometimes there might be some randomness to it, but most of the time there's definitely a reason, and it really has to do with some type of maximizing and doing things in a way that produces the best effects. So you'll see that spiraling in nature in a variety of different things. Other patterns in nature. Can you find another pattern on your table of different things in nature? And how would you describe it? Okay, I see you picked up the
Beaverton.
no,
Radial
it's
symmetry.
a sea anemone,
Yes.
okay?
See whatty?
I say it wrong, so sea anemone,
And then, let's do Nemo here.
anemone, anemone, thank you,
Kind of like an enemy.
Okay, and
anemone.
we were
Thank you.
calling it radial symmetry.
Yeah, it's a sphere, it's that radial symmetry. If you have what else is done that way?
This is a star
There you
pattern.
go, the sea star.
Nice.
Yep.
The sea star is the same way.
They're so beautiful.
So that is another one. How about any others?
So it seems to have 6 sides, each of the little pieces.
Oh, cool.
And
Yeah. It is beautiful. It's, it fits through. And there's your radial spheres as well. How about there's one I think on this table. This one. This round and round and round pattern. Take your dropper and drop in the water. What do you notice? What pattern is that?
We're dropping a drop of water into our
You have a cup of water, and take a drop.
What, do we need clear?
Unfortunately, then we were blowing bubbles afterwards, so our water might be not as clear. But when you drop water in a drop in water, what do you see? Ripple. And this is a good example. But if you have any bivalve shells, this is a great ripple look. Ripple in sand.
I'm gonna skip them.
So there's your ripple on the sand. There's your radiating, your sea anemone. Here's another one. This is packed. This is really using every single space to be most effective. So when you see honeycomb, there's someone, one table has honeycomb on
I think
it.
the wasp.
Who has
Wasp
that?
nest.
Yeah, the wasp nest there. It uses most effectively all that space. And each one of those is one of the wasps or the bees in it. So it maximizes the space. My corn on the cob, maximizing the space. Is there any space between those? It's totally maximizing it. Using it all. Okay. Why don't you take, and I made sure that everyone took their straws from the last time, but there should be some straws here, and blow some bubbles in your soap. Or look at the bubbles that are already in there. What are you noticing?
The honeycomb.
Can I make an observation,
Sure.
if you don't mind? You know, your slides are great. We just came from the squeaky wheel where we made a movie or trailer with our iPads. And I think that the iPads would be another great tool for having kids also illustrating just what
Absolutely.
you've done, their own patterns that they're discovering in nature, or even from a magazine like National Geographic.
Yes.
It's right in your class.
Oh, yeah, it is.
But
It
if
is.
they can put together a slide or 10, I think they remember it better.
They do, or go out in nature. I think going
Well,
out in nature and
I
actually
know.
seeing it versus going in and finding it in a
I agree,
book.
but.
Yeah, but no, absolutely. Right now, I'm just trying to show the
No, I
science
get,
and
no, I
connection.
know, I was just saying.
But absolutely,
connecting
getting,
everything.
and please don't feel, please share. That's what I like, thank you, Cheryl,
No, it's,
because sharing ideas.
I teach, I'm an art teacher, I constantly teach about nature. Getting out in nature is a little harder, but we try. But I teach 7th and 8th grade, and
Right,
they
so
have
what's
to be,
the
they have
difference
to
to
be
that?
doers. And-
Absolutely,
and so-
absolutely doers. And that's why
Yeah.
I want you to mess with stuff and do.
That's another great thing that you guys do is, you have your biofacts. You guys collect, just start collecting now. You know, even when you're out in your yard, I mean, we have so many different ones that you would obviously, but you can use them as making this print and learning experience. Like today I got to touch a giraffe skull, for example, for a 5th grader. It's gonna blow somebody's mind, you know what I'm saying? So with the Science Museum in the same respect, I mean, these are things you can find.
Yeah, there's a lot that you could do, and we have gardens with School 59, so we go out in the garden, we look at these different patterns as well. So
Awesome.
packing, the other one, next one I mentioned already, is fractals. When you look at and see each individual little one looks like the bigger one. So this is a perfect example of fractal. Cauliflower. You know how you pull each little section of cauliflower, each little section looks like a cauliflower head. That's fractals. Broccoli is the same way. Each little broccoli, so that's a great one to show the different fractals. And then certainly, how would you describe the way leaves are, or branches on a tree? Or your arteries in your body? You're being very nice, I can tell.
No, I was gonna say palmate or something, but I mean, just because I'm a gardener and I know certain things, but
Yeah.
I'm not even sure, because it's not.
Yeah, well, it's just branching, it's just,
Branching,
it's just
okay.
branching.
Reaching.
It's branching in nature. Branching in streams are that way too. So, yeah, there's amazing pictures that you can find, and developing that portfolio, absolutely. Anytime you can get kids to be connected to it, make it more relevant in their lives, that's the way to go about it. And then you need to know your students. You need to know what it is that they would appreciate. And you're right, technology is so big right now. You know, they can make their own website. They can do a blog. I mean, they can add pictures and do a photo journal. Photo journaling is great. Journaling in particular is great. But you do that a lot. I mean, I took a science journal and I started with contour drawing. And again, it's just getting kids to see. The more they see and the more they time spending observing the object versus looking at their paper, which is what you do in contour drawing, the better they get at really seeing. And that's really what it's about. And I'm not an artist, but you spend time and you do that and you realize that by looking at things, you really see the unique little bumps, the little dots on your, seeing them. Okay. Look at it, I gotta watch my time here. Looking at it from our body and looking at it as our body, our masterpiece, and certainly the person that we all think about, the great artist and scientist, of course, is Da Vinci. And so we are looking at our bodies and our body, our Explore You thing, and developing a way for kids to really understand their bodies and their different proportions and things. So if you want to do this, there are some string at your tables. And if you work together, get your height in a piece of string. And we're going to see some different proportions. Many of you might know already. This is one that a lot of people know, is your height. Does anyone know your height? Exactly, is your wingspan. I can tell I'm a biologist, your wingspan. So I'm about 5 feet tall, so for me, when I'm in the store and I have to see how big that dresser is, I just wingspan it and I can figure out things.
Okay. How much were you stepping on?
Good observation.
Just me?
You pitch.
You know what? Let me give you my email, or you give me your email address, I'm gonna have to get that, I don't know.
Let me get your email.
It's K. Wallace.
Pretty much what you said. 6'1", 6'1".
If you take one of my things, you can have for Jody, and she'll do those too, but she's away on vacation, so
.edu.
science.
All right, right here.
Okay, and another question
Now what are we gonna try to
I
figure out?
saw a flyer.
Is this actually, are we supposed to actually be 36 inches from the nose up? That was an old thing.
Yeah.
My grandmother used to
These are the
measure.
programs that we offer to
Like,
students.
I know that's why my arms
So,
is great.
Yes.
so I need to
Yeah,
turn
this
my head to
one's
get that.
My grandmother used to
schools,
measure
these
this
two are.
way.
Yes.
You want to try you?
Differently.
Proportions.
These two.
These two are the results, this one's
Yeah.
ours.
You know, but I guess we should realize you groove in here.
Discover what other kind of proportions you can find.
You're
A
just
little bit of
some sort of mutation.
It's approximate.
Put your head straight up.
But I mean, even when you look at things like
Okay, you
torso,
straight.
legs, like we're supposed to have more
Oh,
legs
she's
and
giving you a
torso.
haircut.
Is it
Way
gray?
more
I'm
testosterone.
getting really gray.
Like, the whole thing.
No, no.
So it's genetic.
So what other proportions can you see?
Your torso.
.org.
Red
You're
and
supposed to have. Is that a little bit more lazy?
But when you look at it, if you look at our bodies, we are the Fibonacci numbers. We have 5 things that come out of our body, our head and our 4 limbs.
You're probably gonna.
We have 3 openings on our mouth, on our face, 2 nostrils on our mouth. We have 5 and 5.
Yeah.
Same on both sides, right?
We're symmetrical?
Well, except one eye's up a little higher than
Do you
the
know,
other.
do you know what? And I will do this for nature, even on the video.
Alright, so right here.
But your foot, do you know what size your foot is in relation to your body?
Okay.
Yeah, it's your upper,
Well, that's actually.
or your lower
that's good.
arm.
Yeah.
So do you ever want to know your shoe
There
size?
it is.
From here to
That's awesome.
exactly to here, what?
You're
Look at
Your
me.
forearm?
Oh,
From your
See, I have-
wrist to your
I
elbow
have more
is your foot size.
at any age, even for kids, if you want to make it.
That's a good
That would
question.
feet.
Is it any age?
I only did it to my chin, yeah, because you're counting your torso here,
These are good for adults.
and then
Yes.
from your waist to your essentially
Yes,
your
so
side.
figure out how many shoulder
So you should
widths
be
is
pretty
your height.
close as you're
So
shaping
no,
your,
Okay, so then.
your leg should have a little bit.
Yeah, but we're about to say one. About three.
It's a little about 3, exactly.
Well, aren't
Yeah, I
we, the proportions are different depending on where you started learning how to draw, whether
They're
it's 7,
approximate, but they're
8 or
approximate.
9.
But everything, I mean, everything is so dependent on genetics.
But no, you know, proportion.
Here, between your wrist and your elbow
One
is your foot size.
7,
Really?
8, more head
I believe
lights,
that,
because
yeah.
they want to divide it
This,
to be
and
more.
right to here, that's your
From
foot
here,
size.
from here to here.
Now it's 8.
Yeah, I believe that.
Do we go by 8?
Let's just do that.
Then, the circumference of your head should be equal to so many of your heights as well. There's a lot of cool proportions that go along with it.
I know, that's what I was telling you.
Your neck,
This will go like this.
ideally your neck, there's a proportion between your neck and your waist. I believe it's 2 necks should be your waist. Then there's a different proportion between your neck and your height. I think it's 10 necks equal height. So it's fun to have kids figure these things out. And then they can figure out math along with it. So there's some really great things, and it really again relates to the Fibonacci sequence. By the way, Body Worlds is coming back, and you get to see the wonderful, beautiful artistry in our bodies. And how about that spiral? Do you have a spiral on your body? Did everyone hear me? Very good. You didn't even need my head. There's that spiral in your ear. Very cool.
Genetics again, I mean, dependent.
Okay, I'm going to turn it over to Sarah.
Hi.
Hey.
How are you guys?
Yes.
Oh, thank you.
And she's going to talk about capillary action. She actually does the program, and she'll go to schools and do this in the school for 2-3 days or whatever. And she connects the science with the art through a whole capillary art project that she could do with a whole class and do a project in the hallway and connect it.
So I am an art teacher. That's what I do. So I try with every one of my lessons to incorporate an interdisciplinary lesson, because I feel when arts are being cut, it's the best way to justify it. If I can teach science in an art class, why not? So that's the way I do it. So we're talking about capillary action, and most of you guys should know what capillary action is. It's how fluids will flow through a surface, or so our bubbles, you can test that too with dye and see how the ink will go through the bubbles and follow its way down. But I have an example of work that I'm doing right now and that we can do with the class. So this is Scherenschnitt. It's the art of cut paper. It's a German form of artwork. Normally it's on white paper, and they just layer up layers of paper. So what I would like to do is I'll come in, and each student will pick a part of the forest. We'll do our artwork, and it'll combine to make an installation. Through these little vials, I started this morning, so you can see how the ink's going to creep up. And it might take an entire day or 2 days, and the larger it is, the longer it'll take. But that's kind of cool, I think. So this is my little example. It's one I did last night.
Cool.
So the bottom tip of the bird, I put in blue ink, and the beak was in yellow. And you can see how the colors bled through the paper to make this artwork. So if
Did
you
you
want to
just lay it
pass
down,
around.
or just?
No, I put it
dip
up on a
in
board
that,
just like this.
Where are the vials?
These little ones right here, these
I
little
can't see them.
specimen containers. I'll bring it around if you'd like to.
Where would an educator buy vials like that?
Science catalogs, but you can do it with anything. Go and collect the junk that you have from little eyedropper containers, anything that's like a little bottle.
Those things that flowers come in, the roses?
Exactly, that would work,
Oh,
yeah.
yeah, it's
Yeah, you can get these in size, we use them for DNA extraction and stuff, but you can use a variety of
I
different
use
things.
drawing paper. What I think about for the paper to use, the cheaper, the better.
Yes.
Okay, because it's gonna have those little holes in it. The expensive paper is made so that colors don't bleed. So this is a drawing paper, but watercolor, cheap watercolor paper will really work really, really well. So that's what I do.
So are those watercolors or
These right here, no, they're dyes. They're food coloring. 'Cause I want
liquid watercolor work?
Yeah, as long as you dilute it, yeah.
Well, temperate paint.
Tempera paint won't work because tempera paint is a solid that we make into a liquid. It's a solution. It's more like when you get chalk wet. Tempera paint is not really a dye. It's a little different. That might be harder to do.
Cool, thanks. Sorry.
And if you're looking for any interdisciplinary lessons, go to the art teacher, go to the music teacher, and talk to them. I had a history teacher come up to me and ask, well, how can I teach World War II history? So we did a photography lesson on propaganda art, and students had to take the same subject matter and show a positive face on it and a negative face. They linked it with World War II propaganda art from the photos of nurses in World War II and how it differed from the actual view. You can do it with all of these lessons, so strive and push yourself to get there.
Then you could also connect, she talks about, making a forest habitat with that. So you can talk about, again, those phases of observation, relationships. Okay, would that owl, what would be predator prey? You could do food chain regarding this. What a cool way to be able to teach all that, again, while using art. Ecosystem. So you might start in your installation doing prey animals, or you might start at the bottom of the food chain. Let's put the plants in first, and then you do the plants. Then you go into the food chain and you add predators, and then you could talk about the prey, and then you might end up doing some recycling or whatever. So it's a great way, and then you could talk very specifically about each individual animal. For example, on some of your tables, I think there's a owl feather. This one's an owl. Did you feel how soft it is? And if you notice the edges are really fringed. And that's what I saw that Sarah was doing on her owl, was she was making it very fringed, which certainly helps with the capillary action. But why are owl feathers fringed like that? Anyone have an idea?
Evolutionary.
Something about the air.
I think so they were quiet.
Exactly.
Silent hunter.
They are silent flyers. These fringes on it help when they fly, the wind goes through it. So versus something like this, you can hear more. And when you hear a flock of pigeons go, you hear them taking off. You hear flight. You do not hear flight when an owl takes off. And then this has been used, this type of design has been used in biomimicry and showing how they have designed the bullet train that's in Japan. They have actually attached the electricity on top through fringes in a way so it's more silent. So looking at this, so you can, again, connect all different things regarding this. Anyone have any thoughts, things that they have tried, and how to connect art and science that they want to share? Different things? Yes.
One thing I've done before is with nature journaling, doing watercolor. So the kids really spend time trying to perfect that color and mimic the color they saw in nature.
Mm-hmm.
It takes more time and more thought.
Yeah, I did one of the great, has anyone been to San Francisco, the Exploratorium? Absolutely wonderful place. That they're moving to a new place in April. But they do a lot of art and perception and things like that. We spent a day where we took watercolor and each of us had to make different shades of green. We had to do 10 different shades of green. Then there was a class of 20 of us, and then we had to take those they're tiny little things, and we had to put our shades of green and categorize them. So you're doing categorizing. You're looking at the different shades and understanding that there are so many different shades in green. And then we took one that we particularly liked. We went outside to find the best closeness to it. So yeah, there's a lot. That's a great idea. So instead of just taking, and what a lot of people do is go to the Home Depot and get the different shades of green, experiment with the watercoloring, actually doing the watercoloring on there. And then they get to see it and then go out and try to find that different shade. Great idea. Any other ideas? And how you connected science with art? And again, motion is a wonderful thing. Talking about, and I don't want to just stay to the visual arts, but there's certainly the music that we're going to be doing, connecting the musical instruments with the sounds of the insects, and actually listening to patterns. Again, there are patterns. Anyone know, have a katydid outside their thing? Katydid, 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 all night long. And there's a definite pattern. And then what does that sound like as far as a musical instrument? So we're going to be doing that things, and we're going to have different instruments and getting kids to, again, hear as well, and connecting those things to science as well. Pattern in all those sounds that we're hearing. So there's a lot of different ways, and I think Sarah is a great example of showing, as an art teacher, how she can, incorporate that into all the different lessons and make those connections. Because there really are a lot of strong connections to it. And it's also, we are seeing STEM, you're the science, technology, engineering, math. Now they've added the A to it.
Art?
It's art.
Awesome.
So it's STEAM. If you Google that, there's a great Scientific American article about it, if you want to see that. But they're saying that art is absolutely critical. It's really important. It's again, technique, technology. So there's that art that they're putting in there. So it's really important. And the visual arts as well as the literary arts. There's work out of Berkeley, University of Berkeley, that talks about the connection between reading an object, reading a landscape. We've been doing a lot of reading, haven't we? We've been reading these objects. Then you go out in nature and you read the landscape. So there's connections between that inquiry, and literacy skills. So reading comprehension and inquiry, strong connections. Reading an object, reading that landscape like Thomas Wolfe talked about, and observation. Those things are all connected. So those are great ways to do it. So we're going to continue to incorporate. We think it's really important in our different studios, our science studios. The next one we have biodiversity, obviously, all this stuff, and showing art and biodiversity and the different patterns in nature. That's going to be very strong in that one. We're doing things with extinction, talking about the importances of animals, not just things that are extinct in the past, but looking at climate change and how that's affecting things like polar bears and things like that. And then we're doing space. So there's a lot of different things. We're going to work in insects as well as doing those really close-up pictures that I had in there, looking at the different things and looking at the marvelous patterns that you see. So I'm going to end with, of course, Albert Einstein, who also saw the real benefit of art and science as well. And if you have any other questions or want to comment, please. Anyone else have experiences?
I mean, you were asking before, it took me a second about science and art, the color spectrum, what is light?
Absolutely.
I teach, when I first start teaching color, we start right with that, and I hand out prisms.
Absolutely. I knew I was running out of time. I had that whole bucket with me.
It took me a second, I'm
Yeah.
like, well, I do it all the time with patterns, but there's something else I do that.
Yeah.
But we've gotten much more respect, thanks to the Common Core, thanks to
Mhm.
7th and 8th grade teachers needing to break out of the box a little,
Mhm.
with them coming to me for, help and
Absolutely.
ideas, and I'm really
Absolutely.
grateful for that.
It's really about, again, using your hands, getting them involved, and what a better way than to doing it through art. So, yeah, and the Common Core, I think, does help to do that really well. The Next Generation Science Standards does it as well. There's those unifying concepts like pattern and systems, matter in systems. There's things like equilibrium. Those are, there's balance in art, there's balance in chemistry, there's balance in the human body. There's that's our unifying concepts. And we talk about, or cross-cutting concepts that the terminology I think they're using now. Those aren't just through science, but they're through art, through everything. And if you think about it, environment is a linchpin. So get your kids outside the best you can. Alrighty.
Thank you.
You're welcome.